So, good afternoon, students. And today we will be rediscussing the chapter Matters in Our Surrounding. Okay, though we have discussed this chapter, and now once again we will be revising with this chapter the key concept. Okay, now, first of all, before starting with this chapter, anything which occupies space and has mass is called matter. For example, air, rice, water, chalk. Non-examples like this question is asked in the NCERT also, that is a smell, whether it is matter or not. Definitely it is not a matter. So anything which occupies space and has mass is called matter. Can anyone say what are the properties of matter? What are the properties of matter? Anyone? Okay, Ayush. Unmute yourself, Ayush.
Yes, sir. Particles of matter attract each other. Particles of matter continuously moving. Or, sir,
Okay,
particles of matter have some mass.
okay, very good. Okay, okay, Ayush, good. Now, before go, yes, definitely, student, just to we can say you ignite you regarding the matter. I have directly went to the features, or we have said that what are the characteristics of the particles of the matter. But before going into the features or the characteristics of the particles of the matter, let us first discuss the classification of matter. Now, earlier, the Indian philosophers, they thought that, or they classified the matter as in the form of five basic elements, the Panch Tattva, air, earth, fire, sky, and water. And on the basis of the physical state of the matter, we know that there are three states of matter: solid, liquid, and gas. On the chemical composition, there are two types: pure substance and mixture. This we will study in chapter 2. Okay, so this was the previous belief, but now we will come to the physical nature of matter. Definitely, all the physical nature of the matter, one by one, we will be discussing. With some activities also we will discuss, which will make it more clear. First, matter is made up of particles. Okay, the particles of the matter are very tiny. They have spaces between them. They are continuously moving and they attract each other. Now, let us first see this activity, that the particles of the matter is made up of particles. For this activity, what is the activity? Here we have to take some water in a beaker and we will note the level of it. We will first dissolve some salt, even we can dissolve sugar in it with the help of the glass rod, and the salt dissolve in the water, or if the sugar is also we are using, the sugar also get dissolved in the water, but the level of the water is not changing. This is the main point. The key point in this activity is that the level of the water is not changing. Okay, can anyone recite, or sorry, can anyone recall why does the level of the water is not changing? Why does the level of the water is not changing? Again, the same hand, Ayush. I want okay, this time Nandini. Nandini, unmute yourself.
Yes, sir.
Yes, Nandini.
Sir, because water have spaces between them.
Water has, the particles of the water has spaces between them into which this particle get dissolved. Okay, this activity can be visualized from the image also, which is there in just a moment on the screen. Yes, it is there on the screen also. You can see very well. You can see very well in this image that the particle of the water magnified millions of times. Here we are adding sugar, we are stirring it, but the level does not rises. That means they have the spaces between them. Okay. now. Okay, can anyone discuss what is the activity which is shown in this figure? Just now we have discussed. What is the activity? Can anyone say? Can anyone? Yes, Ayush is very active. Ayush is extremely active in the class. Okay, Ayush, unmute yourself. Tell the
सर इस
activity,
एक्टिविटी में
Ayush.
बताया गया कि सर इस एक्टिविटी में बताया गया कि ये एक पानी लिए उसमें हम लोग शुगर डिजोल्व किए और वो शुगर डिजोल्व हो गया पर वाटर का लेवल बढ़ा नहीं क्योंकि जो स्टेट ये पार्टिकल्स है जो लिक्विड का उसमें स्पेस है
Okay, fine, Ayush.
और स्मॉल पार्टिकल्स है।
Okay. Abhinav, unmute yourself.
Yes, sir.
Abhinav, can you demonstrate or sorry, not demonstrate? Can you recall and you can say what is going on in this activity? What is going
Yes,
on in
sir.
this activity?
The
Yeah.
particles of matter have a spaces between them.
Okay, particles of the matter. How this activity is performed? I want to know that part. How this activity is performed? What is done in this activity, Abhinav?
The particles of sugar are mixed with the particles of water.
Okay. Okay, correct. Okay, Abhinav, good. Next, students, we will be discussing the second characteristics of the particle of the matter, that the particle are extremely tiny. Now, for this, students, what is done in this activity? We will dissolve crystals of potassium permanganate, it is pink in color, in 100 ml of the water, the first case. You can see very well here that the color is extremely deep. Here the color is extremely deep. Now what we will do, we will take out 10 ml of this solution and we will add it in another 100 ml of water. The color you can see, the color fainted. If you will compare these two, the color fainted. Now what we'll do, we will take out 10 ml of this solution and we will add it in another beaker containing 100 ml of the water. The color difference you can very well see is getting lighter and lighter. And ultimately at the end, if we are taking out 10 ml of this, we are adding, it is becoming very light. So this means that the crystals of potassium permanganate can color a large volume of the water because there are millions of tiny particles in each crystals. We are not saying that the color is getting nil. If the color is getting nil, that means we will say that potassium permanganate is no more there in the solution. But it is there in the solution because there are tiny particles in each crystals. And that is why the color we are getting in each and every cases. Though the color is lighter, that means the density of the particle is going on decreasing. Okay, the number or the population of the particle is going on decreasing. Is it clear? Is it clear to all? This activity is clear to all, which shows that the particles of the matter are very tiny. Is it clear? All the students, through the chat box, you give me the reply. Okay, Harsh. Harsh, can you discuss with us what is going on in this activity which I am showing you, which I have shown you in the this slide? Yes.
This
Harsh?
activity shows that particles of matter have a space between them and the particles of matter attract each other. In this activity, we can see that when we put uh, uh, 2 to 3 crystals of potassium permanent in 100 ml of water in a beaker, we can see that the particles of potassium permanent get mixed up with the particles of water. And when we take out 10 ml of that solution in another 100 ml of water, we
Very
can
good.
see that the color will become lighter due to because the amount of particles of potassium permanent become lesser than the before, and the amount of water particles is more than before. And
Ve-
this happens, this cycle, this happens when we do this continuously. We can see that the water color will become lighter and lighter.
Very good, Harsh. Very well explained. Very good. All the matters you have very clearly explained. Now, let us come to the next activity, which will show, okay, this we have already done. Particles of the matter are continuously moving. Okay, particles of the matter are continuously moving. For this activity, what we are doing, we will take some water in a beaker and put some drop of blue or red ink along the side of the beaker. We will leave it undisturbed for some time, and what we will observe that the ink has spread evenly throughout the water due to the movement of the particles of water and ink, and the intermixing of the two or more different type of the matter on its own, that is called the diffusion. So if there would not have been the particles would not have been continuously moving, can we expect that the ink should spread evenly throughout the water? Yes or no? What will be your answer? You can write in the chat box. If I say that the particles are not moving, can you expect this ink to spread evenly throughout the water? No, Abhinav, listen to my question. Yes, correct. Nandini, Ayush, yes, you all are. Yes, no, correct. Very good. So this demonstrates that the particles of the matter are continuously moving. Next, particles of the matter attract each other. For this, what we will be doing? The particles of the matter is attracting each other. We will take some iron nail, piece of chalk, rubber band. Try breaking them by hammering, cutting, or stretching. We'll see it is easier to break chalk, less easier to break the rubber band, and it is difficult to break the iron nail. Okay, now can you tell me, student, from this activity why it is difficult to break the iron nail? Why it is difficult or getting a problematic area? Okay, Harsh, unmute yourself.
It is easy to cut a chalk because the force of attraction between chalk is less than the others, and it
Harsh.
is
Okay. One only for you, only one. Next, let me allow other student also. Nandini, apart from which, why it is easier, it is tough to break. Sorry, Nandini, yes, it is tough to break the iron.
Sir, because solid have high density and their particles do not have a spaces between them.
Yes, they are tightly packed and it is very difficult for them to break. Okay, good, Nandini. Okay, so this activity definitely proves that the particles of the matter are attracting each other. If it is a solid, the attraction is maximum. If it is liquid, attraction is less than the solid. And if it is gas, the attraction is least. Next, student, the three states of matter. We have the solid, liquid, and gas. Now, let us have the discussion with the properties. Here, in the first image, it's a solid, second image, it's a liquid, and third image is the gas. Definitely the solid holds shape, it has fixed shape, but liquid take the shape of the container. It has a fixed volume, definitely, and gas, it also takes the shape of the container or the volume of the container. Now here, how we can define a solid? The substance, if it possesses a definite volume and definite shape, definitely that will be called a solid. In this, the constituents are very close to each other and there is not much freedom of movement. Why not much freedom of movement? Because the particles are tightly packed. Okay. Then we will be coming to liquid. A substance is said to be liquid if it possesses a definite volume but no definite shape. And they take the shape of the vessel in which they are put. That means it is taking the shape of the container. Particles are definitely close to each other, but they can move around. And in gas, it's neither possessing a definite volume nor a definite shape. For example, these are the name of some gases. In this, the particles are far apart as compared to present in the solid liquids and their movement. So from this, students, now from this very definition and the features, can you tell me what are the some features of solid? Properties of solid, one by one. One by one, Harsh, you are allowed to say only one property.
Solids have fixed shape, size, and volume.
Okay. Nandini, next property.
Sir, in solid, force of attraction is maximum.
Okay, next Ayush. Ayush, next property. Unmute yourself, Ayush. Apart from these two property which Nandini and Harsh has shared. Yes, Ayush, I think you're not getting my voice. Ayush, unmute yourself, Ayush. Okay, no problem. So ultimately, students,
Yes,
we are
sir.
coming. Okay, Ayush, one more property of
Particles of solid have less compressibility.
okay, we can't compress it much. Okay, good, Ayush. So ultimately, if we sum it up, we'll say that definitely the solid have fixed shape, fixed volume. They have the spaces between them. That is, the space between them is minimum. Force of attraction is maximum because the space is minimum. Movement is minimized. Why? Because the force of attraction is maximum. They are least compressible and the rate of diffusion is also least because of the tight packing of the particles. Now, all the properties of solid which we have discussed now, if you are taking in reference the liquid do not have fixed shape, but they take fixed volume. They take the shape of the container. The shape between the space between the particle is intermediate. Force of attraction is also intermediate, greater, we can say least than the solid. Movement of the particle is intermediate because there are spaces between them. They are also less compressible and the rate of diffusion is more than the solid. And if we compare the liquid, then liquid do not have definite shape or volume. They take the whole space of the container. The space between the particle is maximum and the force of attraction is also minimum. Movement is maximum because the particles are widely spaced and they are most compressible and the rate of diffusion is more than solids and liquids. Now, students, please, all of you tell me one by one the difference between the three states of matter. In a compiled slide, okay, Harsh, only one difference. Only one difference, Harsh.
The particles of solids are less compressible. The particles of liquids are compressible more than solid, but not much. The particles of gas are much compressible than both the state of matter.
Okay, correct. Next, Nandini.
Yes, sir.
Yes,
Sir,
Nandini.
particles of solid are closely packed. Particles of liquid left tightly packed than solid, and
Okay,
gas are loosely packed.
okay, correct. Next, Durgesh. Durgesh, unmute yourself, Durgesh. Durgesh, unmute yourself. Yes, Durgesh, unmute yourself. I'm giving you the option, Durgesh. Okay, no problem. Suryans, unmute yourself. The third difference.
Solid have a fixed shape and fixed volume.
Yes,
Solid
Durgesh.
have a high density, liquid have a more than solid.
Suryans, once again, unmute yourself. Your points were not clear, Suryans.
Yes, sir. Solid have a high density,
Hmm.
liquid had a more than solid, gas have a lowest density.
Okay, fine. Okay, Suryans. Manish is also there in class. Okay, no. He joined, but later on. Okay. Now, students will come to the interconversion of the state of matter. Now, here in this from this image, let us study this from this very image. You can see here in the image, this is a ice. Okay, ice is melting to be converted into water. Water, if you are boiling the water, it is converting into steam. So the particles are close together and cannot move. That is the ice. Water, the particles move further and further, and the particles are far apart and move very quickly. Solid, if heated, converted into liquid. If cooled, then liquid is converted back into solid. Liquid, if heated, converted into gas. Gas, if cooled, is converted into liquid. So these are the different changes, or these are the different states of matter. Now, after this, students, we are coming to the next portion, that is melting or fusion. Melting or fusion, definitely, when a solid is heated, the particles are vibrating with greater speed and begin to move. And then at a particular temperature, when the solid melts into liquid, that particular temperature is called the melting point. And this process of melting is called as melting or fusion. Simultaneously, there is another term, that is a latent heat of fusion. It is the amount of the energy required by 1 kg of the solid to be converted into liquid at the atmospheric pressure at its melting point. So that is the latent heat of fusion. Okay, latent heat of fusion. Again, if you are saying boiling, when the particles are heated, again it began to move even faster. And the stage is at the temperature is there, a particular temperature at which the liquid is converted into vapor, and that temperature is called the boiling point. It is 100 degrees centigrade, the value is 100 degrees centigrade. And again, the latent heat of vaporization, similar to like that of latent heat of fusion, only difference is the change of state. Amount of the heat energy required to change 1 kg of the liquid into gas at the atmospheric pressure. That is the latent heat of vaporization. You can see here, students, sublimation. What is sublimation? Definitely the change of the state directly from the solid to gas or from gas to solid. That is the sublimation. Okay. Now, here is an activity given over here, that if a camphor of the or ammonium chloride is heated, it changes into vapor. And if this vapor are cooled, it changes into solid again. For this activity, what we have to do is that we will take a burner. Okay, we will take a burner, and this a china dish is kept on it on the tripod stand. Then ammonium chloride is there, that is a camphor. If heated, the ammonium chloride vaporizes and it is collected over here, inverted funnel. Okay, now if it is cooled, this ammonium chloride solidifies. Okay, ammonium chloride solidified. So here we can see the interconversion between the states of matter. Yes, Harsh. Yes. Okay. Okay, student, before going to that, let me ask you one question so that I will also understand how much you are acquiring. Can anyone tell me the difference between latent heat of vaporization and latent heat of fusion? Again, the same hand, same hand. I want other students also. Simran, unmute yourself, Simran. Simran, unmute yourself. What is the difference, Simran, with the latent heat of fusion and latent heat of vaporization? Simran. Simran also, I think. Okay. One by one. Okay. First, Ayush.
So latent heat of fusion, it is the amount of heat energy in the term of joule required to change 1 kg of solid into liquid. Where latent heat of vaporization, it is the amount of heat energy in a joule required to convert the 1 kg of liquid at the boiling point into gaseous.
Into gaseous state. Okay. And now, Harsh, can you discuss the activity which we have discussed just now, that regarding sublimation? Regarding sublimation.
The activity shown here is known as the sublimation. If in water, the camphor and sand, other things are mixed in water, substances like camphor and sand are mixed, we can
Yes.
separate the items by the process of sublimation.
Okay. Correct. Very good, Harsh. Now, students, here I would like to give you an assignment. All of you, take out your copies. You write a question. Tabulate the difference between the three states of matter. So this is the assignment, student, the differentiation between the three states of matter. Okay, students, you have done your assignment. Okay. And okay, student, just our class is going to end. So in our next class, that is tomorrow, again, we will continue with the effect of the pressure on the states of the matter. In this, we are ending today's class. Thank you, everyone. Yes, yes, Abhinav, I was seen your. Yes, I've seen your work, Abhinav. Yes.